Guys, let's continue. So as I told you before, we are starting inverse Laplace transform. So what is inverse Laplace transform? So if you have Laplace of ft is equal to fs, then you can write Laplace inverse of fs as ft. This is just a way of writing. For example, when you know that you have sine pi by 6 as half, then you write sine inverse of half as pi by 6. So this is just a way of writing, okay? So ignore this. So let's take an example. You know that Laplace of 1 is 1 by s. So Laplace inverse of 1 by s is 1. Laplace of e raised to minus at is 1 upon s plus a. So Laplace inverse of 1 upon s plus a is e raised to minus at. Laplace of sine at is a divided by s square plus a square. So Laplace inverse of a divided by s square plus a square is sine at. Or you can also write Laplace inverse of 1 upon s square plus a square is 1 by a sine at, and so on for all the functions that we have done. So now, just like we did properties of Laplace transform, we have properties of inverse Laplace transform. So the properties are very similar, so you won't have to remember with them separately. For example, the first one is again change of scale. So if Laplace inverse of fs is ft, then Laplace inverse of f of as is 1 by a f of t by a. Example, let's take this question. Find Laplace inverse of s divided by a square s square plus b square. So you can write this as 1 by a Laplace inverse of as divided by as whole square plus b square. So if you look at this closely, this is actually 1 by a cos b t by a. So your answer becomes 1 by a square cos bt by a. Remember guys, we have written t by a because of this property, and the 1 by a comes from here. Let's look at the second property. It's again your first shifting theorem. So if Laplace inverse of fs is ft, then Laplace inverse of f of s minus a is e at multiplied by ft. Or if you have Laplace inverse of f of s plus a, then it's e raised to minus at multiplied by ft. Now you have second shifting theorem. See guys, I'm telling you all the properties at once, and then we can look at a couple of examples at the same time. So here you have, if Laplace inverse of fs is equal to ft, then Laplace inverse of e raised to minus as times fs is ft minus a multiplied by ut minus a, where u is your unit step function. For example, if you have Laplace inverse of e raised to minus as divided by s. So if you write fs as 1 by s, then Laplace inverse of 1 by s becomes 1. So this is basically your ft. So Laplace inverse of e raised to minus as divided by s becomes ft minus a multiplied by ut minus a. Now ft is a constant, so it won't change. So 1 multiplied by ut minus a. So the answer becomes ut minus a. Your next property is division by s. So if Laplace inverse of fs is equal to ft, then Laplace inverse of fs divided by s is integral 0 to t ft dt. For example, you can take Laplace inverse of 1 divided by s into s plus 2. So Laplace inverse of 1 by s plus 2 is e raised to minus 2t. This becomes your ft. So Laplace inverse of 1 divided by s multiplied by s plus 2 becomes 0 to t e raised to minus 2t dt. So you get e raised to minus 2t divided by minus 2, 0 to t. So this becomes minus 1 by 2 e raised to minus 2t minus 1. Or you can write this as 1 minus e raised to minus 2t divided by 2. Now let's look at the next property. This is Laplace inverse of derivatives. So if Laplace inverse of fs is ft, then Laplace inverse of d by ds of fs is minus t multiplied by ft. So we can write this as minus t multiplied by Laplace inverse of fs, as this is the value of ft. Now I'm gonna take this minus t to that side. So you get Laplace inverse of fs as minus 1 by t Laplace inverse of d by ds of fs. So remember this as well as this. For example, let's take a question. Laplace inverse of log of s plus a divided by s plus b. So you can write this as minus 1 by t Laplace inverse of d by ds of log s plus a divided by s plus b. So let's write this as d by ds of log s plus a minus log s plus b. Now let's differentiate. You're gonna get 1 by s plus a minus 1 by s plus b. So this becomes minus 1 by t. Now Laplace inverse of 1 by s plus a is e raised to minus at minus, now Laplace inverse of 1 upon s plus b is e raised to minus bt. So you can take the minus sign inside and you can directly write it as e raised to minus bt minus e raised to minus at divided by t. This is the answer. So whenever you have log or tan or cot, we do not know the Laplace inverse directly, so you will be using this formula. So you can take out the derivative and use the Laplace inverse of that instead. Let's look at the next property. It's Laplace inverse of integrals. So again, if Laplace inverse of fs is ft, then Laplace inverse of integral s to infinity fs ds is ft upon t. We have seen this in division by t in the properties of Laplace transform. So again, let's write this as Laplace inverse of integral s to infinity fs ds is equal to 1 by t Laplace inverse fs. So your Laplace inverse fs becomes t times Laplace inverse integral s to infinity fs ds. So these types of questions will take a little practice. So let's take one example. For example, you have Laplace inverse of s divided by s square plus a square whole square. Now we do not know how to solve this directly, so I'm gonna write s square plus a square as x. So 2s ds becomes dx. So you can write s ds is equal to dx by 2, and you can write s ds divided by s square plus a square whole square as 1 by x square dx. By 2. Now let's continue. Integral s to infinity fs ds is integral s to infinity s upon s square plus a square whole square ds. Now when I replace this with this, you're gonna get 1 by x square dx by 2. Let's ignore the limits for now. So this will become minus 1 by 2x Now let's replace x with s square plus a square. So you have minus 1 by 2 s square plus a square, and your limits are s to infinity. So I'm going to take minus 1 by 2 outside. When you put the limit as infinity, you'll get 0. Minus 1 by s square plus a square. So you're gonna get 1 by 2 s square plus a square. So you have this answer, but what we actually need is this. So let's continue. Laplace inverse of fs will be t times Laplace inverse of integral s to infinity fs ds, which we have just calculated. So this is t times Laplace inverse of 1 divided by 2 s square plus a square. So this is t into 1 by 2 into 1 by a sine at. So your answer becomes t by 2a sine at. So these were all the properties that you will be using. Remember the integrals and derivatives properties especially. And if you guys have any doubts, leave them in the comment section and make sure you practice a lot of questions. They are given in the notes. So if you guys have any doubts in the notes, you can leave them in the comment section as well and I'll answer. Thank you.